First of all, you should have a nice user interface in front of you. If you have any question to ask, there is a button, question button. Just open that one and type your question. I will answer to any question at the end of this presentation. So today we're going to talk about mobile optimization. A little bit of introduction before getting in the real topic, so at least you know who is talking. My name is Arianna. I'm Italian and currently sitting in Milan. I work as field engineer at Varnish Software. I've been working there for 3.5 years, and I work with the core team at Varnish Software, deeply involved onto support duties. So most likely you might have heard or got a reply from me sooner or later in your career. And whenever I'm not working, I love traveling and I do a lot of sport as well. So now you more or less know the face of the person who is talking today. As I said, I work for Varnish Software, and we are the company behind the famous open source web accelerator Varnish Cache. You most likely have heard of it. And obviously, we do develop community software. We do develop good part of the code of Varnish Cache, but we also have other products or other solutions such as Varnish Plus, Varnish Extend, and the Varnish API engine. So today the solutions slash features we are going to have a look at are part of the Varnish Plus package. So there is some sort of assumption today. I know the topic is mobile optimization, but I need to make sure that you all know what caching really means and you all cache content already. That's why I need to introduce a little bit Varnish Cache. So Varnish Cache is nothing else but an HTTP reverse proxy, and all it does is caching. Varnish Cache is the open source version. Varnish Plus is a very much enhanced version of Varnish Cache. So basically, it's Varnish Cache plus way more features and other type of solution. If you've heard of Varnish Cache, it's most likely because it gives you a lot of freedom and flexibility, and that's thanks to the Varnish configuration language. And the idea behind caching is that you want to reduce the strain on your backends, but you also want to have a faster response for your final user. So it will look something like this. We have a client, a Varnish sitting in between the client and your backend. The backend is nothing but a web server, so basically something that generates content. A backend fetch requires something like 150 milliseconds as time to first byte. So if the client issue a request, and this request needs to be, and the response for this request needs to be generated by the backend, the time to first byte will most likely take 150 milliseconds. While if the client issue a request, and this request is actually fulfilled by Varnish, that time to first byte is reduced to 30 microseconds. So that's the assumption we're going to have for today. You need to have caching in place somewhere in your architecture. And then, of course, I'm going to introduce three other features which will help to improve your mobile delivery. Couple of words on why we have decided to talk about mobile performance. And actually, there are a lot of reasons behind it. But I've decided just to bring up three of them. And the asterisk at the end of each sentence, it's because at the end of the presentation, there is a slide where I've listed the sources for those numbers. I'm sure you have already noticed, but Cisco has predicted that by 2020, mobile traffic will bypass desktop traffic. 2020, it's 2.5 years from now. It's not that far down the road, and if you need to make changes to your website, it's time to start. And the interesting fact of this presentation is that I'm sure we are all both users, because I'm pretty sure each of you listening to me in this moment has at least a smartphone. But at the same time, we are also the technical people trying to provide a better user experience for our final users. So not sure if you have noticed, but we have somehow got used to speed and performance. So whenever we use our desktop or whenever we use our laptop, we have a very good internet connection, no matter if it's Wi-Fi or if it's a wired connection. And somehow we do expect to have the same type of good connection whenever we use a mobile connection. And I'm not talking about Wi-Fi, mobile connected on Wi-Fi. I'm talking about mobile using 3G, 4G. I'm talking about that scenario where you're driving, you're using your navigator through your mobile, and you're in a tunnel and you suddenly lose any 3G connection. So I'm pretty sure I don't really need to explain and say more about mobile performance. On the top of this, so we got used to speed, but also the average page size for each website has increased. Just to give you some number, in 1995, the average page size was 14K. In 2010, it got around 700 kilobytes. And in 2016, it was around 2,500 kilobytes. So basically, we try to push way more bytes nowadays than years ago, but mobile connection hasn't really changed. Like the infrastructure hasn't really changed that much. So obviously, mobile connection is not the optimal. It's not optimal connection, and we try to somehow improve performance using software and some sort of other hardware. Okay, now we can actually, now that we have a good overview on everything, we can actually get this going for real. So Varnish Plus, which again is the super enhanced version of Varnish Cache, has at least 3 features or solution which can help to improve mobile performance. First one is SSL TLS. I know this is going to be controversial, but I find it extremely interesting. Then we're going to talk about Parallel ESI and Edgestash. So SSL and TLS and mobile delivery. First of all, a couple of words on SSL TLS. SSL stands for Secure Sockets Layer, while TLS stands for Transport Layer Security. And I'm not sure if you know about this or not, but they are the same protocol. TLS is just the newer version, and the name has changed due to copyright reason, but nothing really else has changed. The idea is that implementing SSL TLS, we want to provide privacy and data integrity. And basically, we want to encrypt any bytes to web application might exchange. So for instance, you might be at a coffee place. Usually in coffee places, you have open Wi-Fi and you will need to buy a train ticket. Since you will have to use your credit card credential in order to buy that train ticket, you want to make sure that those credit card credentials are actually encrypted. And you're sitting in a public place and you're not going to use, it's best practice not to use an open Wi-Fi. And that's because it will help you to avoid man-in-the-middle attacks. So most likely you're going to rely on your 3G, 4G connection. And you obviously want to make sure that everything is secure, and somehow that transaction will be more or less, will be quite fast as well. And that's what I'm going to try to prove to you later. So around the SSL and TLS, there are actually a lot of stereotypes and misconceptions which are not true anymore. So SSL TLS, it's a quite old protocol, and there is a lot of discussion ongoing about this. And someone sustains that it is computationally expensive, and I will say it's not, or it's not anymore. Today we have actually very good hardware which can keep up with no problem at all with SSL and TLS. Obviously, if you have to encrypt or decrypt data it will require some more hardware resources, but that's absolutely fine. It's not that if you have performance issues due to your SSL or TLS connection. It's network intensive. Again, this is not true. When you issue a secure connection, there is an extra step to be taken, which is called handshake. So basically, the two applications will have to handshake and make sure they both agree that connection will be a secure connection. This is just a very small step compared to whatever else is going on the same type of network. So I will say that if there is any sort of network problem, it's mostly due to the number of packets we try to send on that network and not to the fact that we need to issue an handshake to get a secure connection. It's bad for performance. Again, this is wrong. I'm not going to say that you will have to implement SSL and TLS everywhere, but there is a specific case, and it does regards mobile connection, where it actually improves your performance. Varnish doesn't support SSL TLS. Again, that's wrong. So Varnish Cache, the open source version, doesn't link against the OpenSSL library. And it does support SSL on the client side. So basically the connection happening between the client and Varnish. Varnish Plus does support SSL and TLS both on client side and backend side. And we do link the OpenSSL library. So now that we sort of agree that SSL TLS is not the worst thing in the world, I'm going to say why it is important for mobile delivery. So when you have a 3G, 4G connection, that connection is actually provided by mobile carriers, and they do use proxies to reduce the bandwidth. Obviously, an encrypted data gets filtered by those proxies, while encrypted data bypasses proxies, which basically means that you are delivering content faster to the final user, and you're doing nothing but simply encrypting data. Again, this will require some more resources to be used at the very beginning when you generate data and when you issue the request, when you start the connection. But in the end, you will definitely gain performance when it comes to deliver data for the final user. Just to give you a very simple example on how this is supported by Varnish Plus. On the left, we have a mobile, tablet, anything relying on a 3G, 4G connection. In the center, we have Varnish Plus, and on the right, we have three different web servers. It's just three is just arbitrary number. It can be as many web servers as you want. And again, we do have SSL and TLS support both on client side and backend side. On client side, we use an open source project developed by us at Varnish Software, and it's called Hitch, and it is an SSL terminator. It's fully supported, and it's also quite, I would say it's very easy to implement. On the backend side, that's a Varnish Plus only feature, and again, this is super easy to implement as well. It's just a matter of switching it on or off. So for instance, if you have 3 backends and you want to implement SSL support only for 2 of these 3 backends, you're going to ask Varnish to switch SSL support for backend number 1 and backend number 2, while backend number 3 will just use regular connection and not secure connection. So up till now, we have discussed about SSL, and that's the first feature, and it is extremely important to get the best out of your connection. So if you do implement it, you will bypass proxies and you will deliver content faster to the final user. Now we get into another solution or another feature, Parallel ESI, and this will help you to get faster content delivery and also personalized content for the final user. Couple of words on what CSI is. So ESI stands for Edge Size Include, and it is a technology developed in 1999 by Oracle and Akamai. And the idea behind it, it's quite simple. Let's take a web page as the one you have in front of you, the purple and the blue one, and let's divide it into several fragments. So we can cache each of the fragments individually. So for instance, we have the trending fragment over here. Without ESI in place, if this trending fragment changes once every 5 minutes, and that's very likely to happen, you will have to nuke the whole page from your cache and issue a new backend request in order to reintroduce a fresh page with the updated trending section. With ESI included, instead, you will get several fragments. So if your trending fragment changes, you can simply nuke this one, this little piece over here, and issue a backend request asking for a brand new trending fragments. Obviously, these reduce the bandwidth use. It's faster to generate because you can decide which kind of caching policy you want to put in place for each of your fragments. So overall, already ESI is very good when it comes to personalized content for the final user. It's an HTML markup, and it really looks something like this in your HTML. So basically, for instance, for a logged in user, you want to include user data, specific user data, and you will simply include that piece of fragment and fetch it from either from the backend or from your Varnish Plus. Now, both Varnish Cache and Varnish Plus do support ESI, but there is a difference in how they actually handle backend fetches. When it comes to Varnish Cache, we have, in this simple example, we have on the left the web page we want to actually render, and this web page has 4 different ESI include. So the client sends a request to Varnish Cache. Varnish Cache at first doesn't have any of those 4 fragments in cache, so it will have to, first of all, trigger a first request to get the title. Then it will have to trigger a backend request to get the main article. Then a third request to get the social media fragment, and then the 4th request to get the what's trending fragment. In the end, Varnish Cache will be able to actually get a response to the client. Well, if you have Varnish Plus in place with the exact same scenario, so web page with 4 fragments, the client will issue a request. Varnish Plus doesn't have anything in place still. Varnish Plus will issue 4 backend requests altogether to fetch the 4 fragments and eventually reply back to the client. As you might have noticed, there is actually a big difference between how Varnish Cache handle ESI and how Varnish Plus handle ESI. So Varnish Cache treat each fragment, process each fragment in a serial way. So if we have 10 fragments and each of these fragments takes 10 milliseconds, I know that's a big number. Before the final client is actually able to render the page, it will take at least 100 milliseconds. With Varnish Plus, if we have 10 fragments to be fetched from the backend, and each of the fragments takes 10 milliseconds, the end user will actually see the page after 10 milliseconds instead of 100 milliseconds. Like, just have a look at the GIF here, and it really does explain the performance boost you get if you have parallel ESI in place. Overall, actually, a customer of ours, Amedia, helped us to test this properly, and they saw up to 50% reduction in time to first byte. So if you do implement parallel ESI, and you don't really need to implement it, you simply need to run the latest Varnish Plus release, and that works out of the box, but you will see a positive performance impact on any website using ESI, reduction in time to first byte, and this obviously will give you the freedom to create a more personalized experience for your final user, which is extremely important, especially on mobile, or if you have a website and you have to make business out of it. So up till now, TLS to get the best out of your connectivity, Parallel ESI to provide a faster content delivery and more personalized experience for the user. And now we get into the last feature, and that's Edgestash. Edgestash is a feature that lets you assemble your page on the Edge side instead of the client side. It's a mustache-inspired templating, and it basically moves the responsibility from your web browser to your Edge. Again, in this scenario, I'm going to assume you have Varnish Plus at the edge of your architecture doing caching and delivering content to your client. And if you also implement Edgestash, you're definitely going to have a lot of benefits out of it. The markup, again, it's super easy. We have a JSON file over here on the right, while on the left there is the markup. And we do check if the name, if there is a key called name and it does have a value in the JSON file, then we're going to use that value. Otherwise, we're going to write something else. So the logic is super easy. If this key exists in the JSON file, then use it. If it doesn't exist, then do something else. And that's pretty much it. And the idea behind it is that nowadays, as I've mentioned at the very beginning of the presentation, the average web page size is 2.5 kilobytes. And that's because web browser will first have to go to the server and ask for a template, and then they will have to ask for a JavaScript library, and then for JSON data, and then for other images, and then possibly a link to something else. So there are a lot of round trips to be done by a web browser before it is actually able to render the page, and it does consume a lot of bandwidth, which is extremely important when it comes to mobile connection. I'm not sure if it's correct if it's true all over the world, but like in Italy, you still have to pay a lot to get 1 gigabyte extra at the end of the month. So you definitely want to save on that. So if you don't have Edgestash in place, let's consider this scenario. On the left, the white page you see here, that's a final web page the user wants to see rendered. So the client will have to issue a page template request. And we as user looking at our phone, we will first see some content rendered here. Eventually, the client will send another request to the server asking for a JavaScript library. And that's a second round trip we take. It does receive the JavaScript library, but without a JSON file, we can't really render anything. So it's basically 3 round trips before the web browser is able to render the page to the final user. Well, if you do implement Edgestash, the same exact scenario, the client will have to send a request to the web server for a pre-rendered page, and the content will be visualized and rendered to the final user. So without Edgestash, we need to use way more round trips and way more bandwidth before the user is able to check the web page he or she has requested for. While if you do have Edgestash at the edge of your architecture with Varnish Plus in place doing caching as well, we simply pre-assemble everything at the edge. And in a single round trip, we're able to give to the final user the page she or he has requested for. This obviously reduces the amount of round trip and reduce the bandwidth that needs to be used in order to render a page. And again, it allows you to give a better user experience and more engagement. So overall, we have 3 features which can help you to get the best out of your connectivity, get a better user experience, more personalized content, which is extremely important for anyone running e-commerce or anyone doing business out of website. And those 3 components are part of the Varnish Plus package. So full SSL support is already in Varnish Plus. Parallel ESI, it's there. You don't have to do anything. Just run the latest Varnish Plus and you will benefit. Edgestash will be available in the next Varnish Plus release. It's currently it's a couple of customers of ours are running Edgestash in production and they're very happy with it at the moment. That's why we have decided to push it in the next Varnish Plus release, because it's now ready to go and it's ready for you to be used. So takeaways from this presentation, the bullet points, you are able to read those bullet points, but my personal suggestion is do have cache in place, and that's the first step. And on the top of that, you will need to consider implementing SSL and TLS to get the best out of your connection. Then you will have to want to implement parallel ESI to personalize more content. Obviously, the fact that it will boost the delivery, it gives you more freedom to have even more ESI fragments, because you're issuing a single backend request for as many ESI fragments you will have to fetch. Doesn't matter if it's 10 or if it's 100. It will still be a single backend request. Less bandwidth, just implement Edgestash. So overall, you can definitely benefit from each of those feature or components. So now I'm very much open to question and answer. I will just show you the last slide with the sources of slide number 3 or 4. I don't really remember. Thank you very much for your time.